Hi guys, good evening. So guys, today is the day one for our network engineer master program, and Rahul is with me to deliver this entire master program. So after a 15-minute introduction on CCNA and CCNP and RC, we'll move to the day one. We decided a few topics to deliver today. So now onward, from today onward, the class is regular. It's Monday to Friday, 9 p.m. is the start time for this particular batch. It's a regular classes. Still, if you are not enrolled, I'm giving a chance to enroll by tomorrow morning or afternoon. Make sure you'll enroll because this today's session is open for everyone. From tomorrow, only the invite for the enrolled people. Okay, so the program which we are starting, that is CCNA, CCNP, and RC, and Palo Alto. So Rahul is gonna take care for the CCNA and CCNP and RC part. So Rahul, over to you.
Thank you, Gaurav. Good evening, everyone. Let me first of all share my screen. Let me know once my screen is visible.
Yeah, Rahul, it's visible.
Awesome. All right. So, guys, this is Rahul. As Gaurav said, I will be taking care of your CCNA and CCNP NRC as well. So, first of all, we are going to start with CCNA, which stands for Cisco Certified Network Associate. Right. So let me give actually a brief introduction about myself before we start. So I have been working, I'm actually a telecommunication engineering graduate. So I've been working in the telecom industry with routing, switching, SD-WAN, MPLS, and your wireless networks, all these with routing and switching being my most major skill. And also I've developed a bit of security in Palo Alto as well. Overall 14 years I've been in troubleshooting, implementing, designing the networks, and so on. It is currently I'm with the network design team, right? So this is the brief introduction about myself. So I've been handling about I've had a training experience of about more than 10 years of training experience. So having said that, we can move towards CCNA. But before that, I just want to know if all of you guys are new to this network industry, or is there somebody who has already been through CCNA and has rejoined to, enhance their knowledge or, get some stronger understanding on the concepts? Is there anyone who has already been through CCNA before this? That's okay. You can just raise your hand. That's okay. I'll understand.
I think Rahul, everyone is new in this domain.
Okay. Okay. So that was just a question, right? Just to make sure that my explanation has to be in layman terms. So if somebody already understands some part of CCNA, or maybe most of you guys, if you already understand CCNA, then talking in network terms will actually make you understand the concepts. But if you do not know any networking terms, then maybe we can use layman terms to make you understand better. That was just to, for myself to get to know where you stand, right? So after that, maybe we can cover the syllabus part. Coming to the syllabus part, here is some of the topics that you will be learning throughout your CCNA course, right? It includes everything that your CCNA certification requires, right? Everything under our syllabus has everything the certification has. So you need not worry about any knowledge or any concept that has been left out, right? So first of all, to start with, we start off with the network fundamentals. Network fundamentals is something that actually gives you a brief knowledge about what is a network. Why do we actually need a network? In the network, we have something known as OSI model, TCP layer, IP layer, right? These might sound a bit technical at first, but once you deep dive into this, you will understand that these network fundamentals are the basic building blocks, are the pillars for what you learn tomorrow, right? Network fundamentals includes what are the basic things that you need to always know for your network to function, right? Just understand that these fundamentals are some building blocks, some basic stuffs that you always need to know, right? The second unit or the second part that we cover is about network access. When I say network access, let's take, guys, are you able to hear me
Yeah, yeah,
clear?
all good.
Yeah.
Oh, all right. All right. All right. The second part is the network access. Now, when I talk about network access, from the heading, you might not understand what a network access is, right? But if I give you an example, now I am the user sitting behind a computer. How do I access my network? Obviously, with my computer. With my computer, what do I connect to? That is known as your access layer, right? That is known as your network access. Means immediately next to your computer, next to the user and his computer, you will join to a network. You will access that network. That is known as network access. Now, some people will know that yes, in my house, I have a computer, right? With the computer, I will join my Wi-Fi. Yes, that is network access, right? With the help of my computer, I will join the router, reach my service provider, and then go to the internet. Yes, that is network access, right? That is all the things. There are all the things that we will learn about network access. Means what are the devices that are connected to my computer, right? Immediately next to my computer, which is allowing me to join the network, right? What are those devices? And what are the technologies used in that access? That is what we need to learn in the network access part. Coming to the third part, IP connectivity. Now you already know that every device has an IP address. But people, you are new to CCNA, you will know that you, by now, you know a general knowledge that yes, all the devices have IP address, but you don't know which devices can be configured with IP address, right? You don't know that because obviously one of our, maybe next to you, something next to you, like your bed, sofa, these cannot be configured with IP addresses. Then which are the devices that we configure an IP address with? Something which has network interface cards, right? The devices which have network interface cards, these can be configured with an address. Why do we configure them with an address? To make them unique, to identify them. This is one of the device. This is one of the device, right? This whole part, IP connectivity, which is your third part, third unit, covers which all devices can be can be assigned an address or a unique identity, and we can have connectivity between them. That is what your IP connectivity talks about, right? Moving to the fourth unit. Now you have already learned about what is the devices, what are the devices that are next to my computer, and they are given IP addresses. You know them. Now, with those IP addresses and the devices, what are the services we can achieve? There are some protocols. I'll tell you about the protocols later, eventually, when we get inside the topics. For now, you can understand that the services are something that we can make use of. For example, Zomato, Swiggy, it's a service, right? You're getting a food delivery through that. Here, there are some protocols, DHCP, SNMP, NAT. These are some services through which you can utilize the network in an efficient way, in a better way, right? These are the services. For example, just talking about the first one, DHCP. We have two computers. You have opened a new organization. You just have two computers. Obviously, you will get inside each of the computer and assign one IP address to each of them. What if you have thousands of computers, as in when your company grows bigger? Obviously, you have to make sure you have a service which automatically provides an IP address to every device as and when it is connected to my company, right? That is a service to make the network usage in a better way, right? Those are the IP services we will talk about. Then, obviously, we have in IP address, we have two types, IP address, IPv4 and IPv6. We will talk about the IPv6 addresses as well. Now, why there are two IP address? One is IP version 4 and IP version 6. You will get to know because IP version 4 is almost, we have utilized almost all the IP addresses, not all the IP address, 70% of the IP addresses, right? So we need some more because nowadays you know that how the technology is improving. Every device is getting an IP address, right? The IP addresses which are already there, it is almost coming to an end. That is the reason they have developed version 6 as well to accommodate more new devices coming into this world, right? Now, Unit 6 actually talks about the security fundamentals. Now, you know that there is a, you know, network access layer. I have a router, I have a switch, I have, connectivity between them. I have a printer in my network. Everything is there. But who can access the printer? Who can access the router? Right? Which port cannot be accessed? Somebody going on the road cannot connect to my router, get his device and connect to my router. That port will be blocked. So, security fundamentals actually talks about once you have connected your network in a desired way, nobody else can do it. Only you can access it. It is talking about securing your network, how your network should be safeguarded. This is what your security fundamentals actually talks about, right? Moving on, we have network management. Network management is, again, a better way of handling our network. For example, I set up my office, right? I set up my office in Noida, right? I have many computers, routers, switches. I've set it up in a desired way, in the way I want. Now, I have come to a different part of the country. From there, how to access my router. From there, if I want to change anything on my network, how do I log into them? These are the protocols, the management protocols, which helps you to log in to your devices, network devices remotely. Okay. You can log into them remotely and make the desired changes. Not only logging in, but through different protocols provide different types of provisions. They have different types of provisions. One tells you what is connected to the device that I am logged in. For example, I am logged into a router. I want to know what are the devices which are connected to my port 1 and port 2. This protocol tells you that. These first two protocols will tell you that. Telnet and SSH will allow you to log into a particular network device remotely. Remotely in the sense you are not near it. You are in some other far place and you want to log into them. This protocols helps you to remotely log into it. Syslog. For example, I logged into a router. I logged into a switch. This syslog is one of the protocol which tells that a person named, let's say Abhishek, let's say another person named Rahul, what time did he log in? What changes he made on the router? All these actions are actually stored on this syslog, and syslog helps us to get the information of logging and the actions. Moving, moving on. In the next unit, you will understand. Now, till now, you have learnt about how to set up a network, right? How to give IP addresses to it, how to secure it so that only you can access and nobody can barge in into your network, and how to use them remotely from a different place. Now you have done all that. But now you have to learn about network design. In which way, if I design my network will be in a working in an efficient manner. For example, I know that there are many high-end phones, right? There are very high-end phones today in the market. Now, every member of the family, even for example, my mom, my dad, they don't know how to use an Android phone. So every member of the family, if they are given a high-end Android phone, even if they do not know to use, that is not an efficient way of managing, right? For similarly, in the network as well, if you try to use high-end switch or a high-end router everywhere, that is obviously increasing your cost. It is obviously increasing your cost. You cannot maintain the network in an efficient manner. This network design tells you where you can use what type of switches, or in what topology you need to connect your network devices so that your cost will be reduced, your functionality will be the same, stable, etc. Right? That is where we learn the network design. After learning the network design, we move to the recently added section into the CCNA, which is nothing but your automation and programmability. Automation is nothing but every time we need not go into the router, make changes, right? Every time we need not do that. We can automate things, right? Every time, for example, if I log into one router, I can only tell that one particular router, your name is router 23. If I want to tell the next router, your name is router 24, then I have to log into the next router, right? is there a tool where I can log in and send the commands to all the routers at once? This section actually helps you do that, right? This section tells you how to have a centralized configuration, centralized management. And also it tells you how to use programming languages to talk to the router or a switch or your any networking device. How to use programming languages. Why do we need to use programming languages? Right? And why do we need artificial intelligence and machine learning for our networks? So, for example, the router, previously, router's memory was 70%, 80% full. Then it stopped working. The router model was maybe 3200. So, artificial intelligence or machine learning has seen those scenarios where the router memory was full for 80% and then it stopped working. So, having seen that scenarios again and again, your machine learning will tell us next time that, hey, again, your memory is full to 80%. Your router might stop working. It will alert us before itself. This is one of the example. But apart from this, there are a lot of things that artificial intelligence and machine learning can do in networking as well, right? Also, it can tell us, hey, your software is very much outdated. You need to install a new one, new software version. Otherwise, your device will not be compatible with the new devices, right? Excuse me. So these are the situations, or you know these are the conditions where we use automation and programmability, and that is why they are of use, right? Now, this is all about we have in our CCNA. These are the things that you will be, you know, learning in our CCNA. Coming to CCNP, NRC, right? We mostly focus on something called as routing. Routing. NRC, when I say CCNP NRC, do not take that as a, another subject. It is nothing but whatever you have learned in your CCNP, it is just an extension of that means you're going more deeper into the concepts. It is not a separate subject, it is the same subject, but you are definitely finding your strength by going deep inside the concept. You will learn about what is routing, what are the different types of routing protocols that we have, what is a VPN. See, EIGRP, OSPF, and BGP. There are different routing protocols. We will get to know what is a routing protocol. What is a VPN, virtual private network? What is that called as? And what are the technologies using which we can configure virtual private network? And after configuring everything, what are the security measures that we take, right? After that, we have some troubleshooting services. Like to troubleshoot the network, what are the things we use?
Guys, one small question. Can anybody answer what is the difference between CCNP Encore and NRC? Anybody? Why we are learning NRC? So, guys, the answer is like under the CCNP enterprise, there are 4, 5, 6 exam. Okay, so Encore is mandatory exam if in case you want to crack a CCNP enterprise certification. And after doing a mandatory exam of NCORE, you have an option to choose NRC, SD-WAN, wireless, automation, anyone you can choose. Then you will be considered as an CCNP Enterprise Certified. In CCNA, we have only one exam, which is 200-301. Once you're giving exam and you pass out, you get the certificate. Yes, you are CCNA certified. But in CCNP, it's totally different. You need to crack a two exam. Out of two, the NCORE is mandatory. Now, the difference between these two is why we are learning NRC, because in the industry, most of the time you supposed to work on routing protocol, which is EIGRP, DNBPN, OSPF, and BGP. So our major focus is to give you a chance where you can handle the real time scenarios and situations in the real time production. This is the reasons we are delivering NRC. Yeah, Rahul, over to you now.
Thank you, Gaurav. So that's the importance of your NRC, right? And these are the units that we will be covering in your CCNP NRC, right? So that is about the syllabus that we discussed as of now. If anybody has any questions, you can raise your hand, or you can, if you are, if you are, hesitant to ask any question on screen, do not worry about that. Nobody knows you here. You can ask any type of silly questions, silliest of questions that you have, because even having a small hesitation might actually stop you from actually learning the concepts, right? Let's move ahead with a brief introduction of today's class, right? Please excuse my handwriting. CCNA comes in a different code, exam code, right? And this is the most recent one that you're learning, right? Means maybe next you will have 200-302 as well. In that, they will add some more syllabus to cover. Maybe they will think that, you know, people should understand more about, SD-WAN. Maybe they will add some SD-WAN syllabus inside CCNA as well, or the basic part. So there will be an upgrade in the code. So this code is nothing but the revision number or the syllabus, right? And you are learning now the recent one. Okay. Now, talking about CCNA 200-301, in the networking, right? In the networking, we have some devices like your computers, switches, routers, firewalls, right? Right? You have printers. These are different network devices that we have. Why not mobile phones? Yes, even that is a networking device. Now, all these are networking devices. Now, when I say, when I ask you guys, can I communicate from this computer to firewall? What you guys would answer? You guys would say, I'm not sure, I don't know. But now I connect a wire between different devices, right? Now, if I say, guys, can I communicate from here to here, from this computer to firewall? Now you say that, yes, probably, maybe, because I see a wire connected from here to here, then here to here, then here to here. Might be it will communicate. Now, the job of a network engineer. administrator is nothing but making the devices communicate with each other. It's not that many people have some confusions saying that if I want to communicate to the browser or maybe firewall or internet, anything, this is the internet. We write usually the internet like this ISP, and then you have another system here. If I want to communicate from here to here, they assume that maybe we are learning how to send the data, how to receive the data. Maybe the data should be in such form. No, it's not that. Network engineer or administrator, his work is to ensure that he has connectivity between two devices. Not only two devices, many devices, right? If when we talk about connectivity, connectivity is done through the cable. From here to the switch, switch to router, router to firewall, firewall to internet, and from internet to another computer. But is that enough? Now, will they be able to talk to each other? No. If this computer generates some information, like hello, network engineer's job is he has to go to the switch, guide the packet to this next path. Then he has to guide this information. Please go to the firewall. Then he has to guide the information here also. Check if everything is okay in the firewall. He'll tell that check if everything is okay in this information. If there is no harm in this information, then guide it through the ISP. Then inside the ISP, they will guide. ISP is service provider. We do not have access to their devices. They will guide our information to the destination. So here in source to destination, we are making sure that the devices are communicating with each other. Our job is the devices are communicating with each other. Whenever you say, please go to Google server, let's say this is Google server, right? Obviously, you guys use Google server now and then, right? You use for many crick info, live score update. You keep inquiring Google server. Please tell me the weather. Please tell me if there are any chances of rain today. You keep inquiring Google server. But from here to the Google server, do we have connectivity? That is our task. We have to make sure of that. Now, no, if just the wire is connected between two devices, that does that mean that the information generated from one computer will it know how to go? No, it will not know. The information is generated by the computer. The information will know only to pass through this wire. But from here, which wire will it take? Which link will it take to reach the destination? We have to guide it, right? That is our job. Having said that, let's talk about the basics of networking, right? When we say the basics of networking, I know that in the network, you know about a few devices like a computer. Now, in the olden days, they actually found out a computer, discovered a computer, right? But having a computer at home without any connection to anybody, it is of no use, right? You agree? There is no use. You have to connect with somebody else. So maybe a neighbor bought a computer as well. Those two connected themselves, they were happy. But as and when the computers were increasing in number, right? The computers did not have so many ports. it just had one port so that only two can connect. But I don't have so many ports in my computer to connect 20 devices or 30 devices. I just have one port. What to do? Now, there came the discovery of something known as a centralized device for connection. Even in your office environment, you would have observed your computers are always connected to switches, something known as switches. Now, in the before generation, we were using something called as a hub, but now there is no hub. So we will not break our head what is a hub, but we will directly start off with what is a switch. Switch is a centralized device for connecting all our computers together. Now, if only these two computers are connected together, only these two can talk. They cannot talk to this group because they don't have any more ports in them, right? But if you connect all the computers to a switch, right? You connect all those to a switch, then anybody can talk to anybody through this switch. See, it can talk to this via switch, it can talk to this via switch, it can talk to this via switch.
Hello.
Yes, I can hear you. You have any question? I think it's by mistake. Anyways, moving on. This is the invention of a centralized device called as a switch. Even in your company environment, all your desktops will be connected through a LAN cable. This is the LAN cable that you connect, and it will always go to a switch, right? So the switch is the first point that your computer meets.
Hello.
Yes?
So in Switch, only two computers need to connect with each other. No other two needs to connect with each other. Then is it possible only two computer can connect with each other at one time, like using the same switch?
Yes, so I'm sorry, Sonam, I did not get your question accurately, but
Mhm.
what you're asking is, are you asking me that if the two computers connected on the same switch, can
No,
they?
no, I'm asking these four computers are connected with one switch, right?
Okay, yeah.
So if one computer needs to connect with another means another computer,
Mhm.
so is it possible?
You can connect
Like
only one computer together.
okay, so
So,
another two computers, there will be no use for that another two computer. They
for
will not
example,
connect.
if you take a look at your PC, you have just one port to connect. Maximum that you can connect is only one computer. If you want to connect another computer, then there is no port on this desktop, right? There is no port. That's the reason we use this guy. Whatever port is there, I will just connect it to a switch. Now, with the help of a switch, I'm able to talk to anybody who has connected to that switch. Does that make sense?
Okay, so like for like computer one, I need to pass on the information to computer four, right?
Okay.
So like it will not pass the information to computer two and computer three.
No, it will not.
Okay.
Because now we have just connected these computers. Later, I will give a separate IP addresses also to these computers, right? So for now, I have just connected these computers. Later, I will configure these computers with IP address, which is not same as others. Now, when I say that computer 1 has to communicate to computer 4, then you can see my information source is 1111. My destination is 1114. So when an information goes into the switch can see that it is only going to the destination 1114. Make sense?
Yeah. Can you provide a real life example for this?
A real life example?
Yeah.
Yeah, sure. So what we'll do is first we will know how the PCs are connected to each other, right? Then we will talk about the addressing scheme, how these are addressed. For example, in your real life, right? This is your computer, okay? Now, this cable that you're talking about, that we are connecting to this computer, this cable is nothing but it is connected to the Ethernet port, right? When you say this is your computer, now here there is a card where you connect your cable, there is a card. This card is known as network interface card, right? Now, now the computer will generate information inside, but through the help of this card, it will send the information outside, or it will process the information which is coming inside to this computer. Now, every NIC card or network interface card on the computer is given a unique address. That address is known as your MAC address. Don't worry. Now, you might think, how do I remember MAC address? How do I remember NIC card, that is network interface card? How do I keep this in mind? You do not have to by heart it at all, because these are the things that we use in every class of ours. So looking at it, in every other class, you will realize that this is the job that we do every day. I don't have to by heart it, right? In every class, you will see that a cable is connected to a network interface card. From the network interface card, right? Obviously, when you talk about your computer, when your computer has an Ethernet port, behind that port, there is a card, network interface card. You connect a cable to it, and you connect it at the other end of the cable to a switch. Now, this
Swim, sir.
card address. Yeah, Nitin?
Sir, do the switches also will have MAC address?
Definitely, definitely. So
Will communicate through initially from desktop to switch MAC address, then it reaches the destination address, or how, sir?
So, for example, if you want to communicate with any device, just understand that it needs to have a MAC address. MAC address nothing but your network interface card address, right? Without network interface card, they won't be able to communicate with each other. Now it has network interface card, then the MAC address, which we talked about, it should have a source MAC, it should have a destination MAC. So I will ask you now, if I want to go from computer which has a MAC address of AA and the switch BB, what is the source and what is the destination?
AA is the source and BB will be the destination.
Exactly, that is your answer, right? So this information, let's say the information now, by now you guys know that the information is in the form of ones and zeros inside the computer. It is not in the form of what are you doing, hello, how are you? No, it is in the form of ones and zeros. Now the computer will generate an information, and after that, just like how we write a letter, and after that we enclose that in an envelope, right? Just like that, the computer will generate an information and it will close that inside an envelope. What is
Encapsulation, you mean?
exactly?
Yes.
That envelope will have the source and the destination IP address. or sorry, MAC address, the NIC card address. Now, the switch will come to know with the envelope if the switch will see that, okay, this is my MAC address. Then, so for example, you have a letter, okay? You see the envelope. From address is somebody, and if the to address is you, what will you do? You will open this envelope, right? And you will read this information, isn't it? Same way, if the switch sees that this information, this MAC address is the address of the switch, then it will tear the outside header. This envelope is known as header. It will tear that and then process this information. We will see how it processes the information. Now, the basic thing that you need to understand is every computer is connected to a switch. Why we need to understand this? Because switch is the centralized point or the first point after the computer. First point in our network. Switch is the first point. Why can't we connect a switch, PC to directly a router? You can, but router comes with only few ports. 10 ports, 20 ports.
In this case, hi, this is Mahesh. In
Sure.
this case, actually, sometimes we have the wireless network, right? If we connect it to the router, is it the same process?
If you connect PC to the net router, that is what you're asking.
Yeah, yeah.
So PC to a router, in the sense you are, let me actually ask you if this is what you're thinking. Are you
Mhm.
talking about your home network where you're connecting your laptop to a router?
Yeah, let's say if our office have the internet wireline.
Mhm.
So yeah, as you said, the wire network, right? Just now you're talking about the wire network, right? UTP.
Right. So, for example, let's say that our Cisco vendor has a router. Now he says, see, I will give you 8 ports on the router only. Now you have in your organization, you have how many PCs you will have? You have 60 workers. Can you connect all 60 computers to your router? Not at all,
Cannot.
right? You cannot. So you will use a switch with a 48 port. Then you will use another switch with 20 port. Then you will connect this switch to another switch, that to one single port on a router. So aren't you saving
In
some
this
port
case,
on the router?
yeah, in this case, can we use the Wi-Fi router in the same network
Correct. Good question. So
apart from the 48 panel?
when you're talking about your Wi-Fi router, remember that your Wi-Fi router is acting as a router also, acting as a switch also, acting as an access point also, right? It is three in one. Your Wi-Fi router is three in one. It is acting as a switch, it is acting as a router, it is acting as an access point. Access point in the sense it is sending out radio waves through which you are communicating wirelessly. Don't worry, we'll go into this. Just an ideology, just an idea.
Okay, thank you, thank you. Yeah, understood.
Okay. It is acting as a switch also, where you connect your computer to it. So for example, you have 3 phones, 4 phones in your home. Those phones are connected to the internet also with each other. They can communicate. Why? Because it is acting as a switch also. How do you say it is acting as a router? Because a router, it is taking me to the service provider and from there to the internet. How do you say it is acting as an access point? Because I'm able to communicate through radio waves. Okay? As simple as that. But I know we went away from the conversation a little bit, but first thing that you need to know, we use a switch in our network as the first entry point. So when I say access layer, network access, we are talking about the switches in the network. Now, what is the function of a switch? How does the switch behave? If I just connect it to the port of a switch, is it making everything functional? We will discuss that. We will discuss that. What is the natural behavior of a switch? What is the, if we want to change the behavior of a switch, what do we need to do? Everything we'll discuss. For the first thing you need to know is switch is a centralized device to which we connect our computers. So the first point in your network is what? You need to know. This is switch. Okay. Now, we came to know about a network device, which is called as a switch. Now we have to discuss about the behavior of a switch. How does the switch behave? We need to discuss that, right? So if you do not have any doubts till now, we can proceed with the behavior of a switch. Are we good to proceed? Any doubts?
Yes, sir. Please
No,
proceed.
sir.
Thank you.
Awesome. All right. Moving on. This is a switch we are talking about, the entry point of our network, right? Now, switch has many ports, right? It has, let's say, the switch has 6 ports, this switch. Now, does every switch has only 6 ports? No, it depends. Depends, right? This is port number 1, port number 2, 3. Let's take it this way. This is connected to one computer. Connected to one computer. Now you decided in your office there are 6 computers. Now you connected the switch with 6 computers. Fine. All good. Now the network interface card address of this PC. Network interface card address is AA. This is BB. Similarly, CC, DD, EE. This is AB. Now why didn't you take FF? I'll tell you why. Okay. Don't worry about that. Just assume that this is AB. Port number 1, 2, 3, 4, 5, 6. Now, this computer generated an information. Now, always remember in networking, we do not break our head. How did this computer generate an information? When I went inside this computer, when I go inside this computer, when I go into Google, and when I say crick info or something, or maybe live score of any match, when I type that inside the browser in the Google, means I'm indirectly wanting to connect to the Google server somewhere over here. This is the internet. On the internet is connected to Google company. Also, Google company has their router and firewall at the end. Okay. But we are just talking about the server here. Now, it generates an information. What is the score for India versus Australia? Information is in the form of ones and zeros. Let's assume that this is our information. Now, every computer, what it does, as and when it generates any information, for now, let's assume that we are not talking about the Google server. We are talking about something called as PC1 to PC5. Okay, or PC6. This is PC6, PC5, PC4, PC3, PC2. PC is nothing but personal computer, okay? Now, this AA generated an information. Once the computer generates an information, always the behavior of a computer is it adds the source. Whoever is generating the information, it will add that in the header. Why? Because even if you write a letter to somebody, obviously in the envelope, you write the from address. Why do you write the from address? Any idea? Why do you write the from address?
so that they can know where it is coming from, where it's
Ex-
originating.
Exactly. When the person whom you are giving this letter, if he wants to respond anything to you, he should know your address, right? So that is why you write the from.
Source to destination. We
So
need to define source to destination. We need to define the source and the destination.
exactly. That's right. And also this person whom you are giving the letter, if that person has to reply you, he should know your address, source address. So you will write the source address also, and you will write the destination address also. And in the real world, we call this as an envelope, right? We put our letter inside an envelope. Here we call this as a header. Header. What kind of header? We'll talk about it. Okay. Now, the switch will get this information. So you got to know the behavior of a computer, right? You got to know the behavior of a computer. If it has an IP address, obviously every computer will have an IP address. If it has an IP address, it will add the from IP address and to IP address as well. That is also called as a header, but it is a layer 3 header. This is a layer 2 header. Now, what is layer 3? What is layer 2? Obviously, we'll discuss in the next class.
Yeah, hi, one more.
Hey, Mahesh. Yeah.
Yeah, you're saying these things like you're trying to experience packet pressure or it's direct
Mahesh,
saying like this.
voice is very feeble. Cannot hear you.
Yeah, now I am audible.
Yeah, you're audible.
Yeah, now you're explaining these things like you are going to explain saving this packet pressure or it's directly like this.
I'll explain you the process, how it works. Whenever we have packet capture, we can do the packet capture in the router as well. So using the routers, I can show you the packet capture as well.
Okay.
Okay?
Yeah.
So guys, whatever we are explaining here, once we are doing a practical, we are gonna prove that whatever we says, that's correct. Don't worry. Because first we need to understand in theoretically the concept also, like what is the logic, why it's work, how it's work.
Right. Exactly. Right. So I said this is a layer 2 header, this is a layer 3 header. Now, what are these different layers? Layers, I will be explaining that in the next class. What are the different layers? Why the layers were made? What is the use of layers? But here we are just understanding the behavior of a switch. Now, if this is generated, this information is generated, and you saw the behavior of a computer. What is the behavior of a computer? If I ask you, now you will say, you got to know. Once it generates an information, it will add the source NIC card address, which is the source MAC address, and it will add the destination NIC card, that is network interface card address, or the destination MAC address as a header. Awesome. Now that information, when it comes to the
Hello,
switch.
sir.
Hey, yes, go ahead.
Hello.
Hey, I can hear you. Can you hear me?
Is there any mechanism for Is there any mechanism that a switch can learn a MAC address from PC?
Definitely, it will. We will understand that in the event. Eventually, we will understand that, right? There is.
Okay, okay.
Yeah. Right. Now,
Sir, hi.
hey,
Just now you talk. This is my share again.
hey, Mahesh.
Just now you said from AA PC1 to PC6, right? If let's say PC6 there is some problem with the wire UTP,
Mhm.
so it will generate AA to AB, then 115, right? IP
No.
address.
So, yeah, understand it in a way. Now, if there is a problem in this wire,
Yeah.
this guy will not know, right? He will generate the information, but the switch will not be able to pass to this guy because there is some problem in the wire. Then
Okay.
this computer is out of network, we'll call them, right? This has gone out of network because the wire that you have connected is broken somewhere in the middle, or maybe it is loose, whatever.
So let's say the 4 is broken, then the network will show the AA to AE or AA to ACC.
No. So there is no shortcuts. So for example, if this is broken, don't assume that the information will go till here, then it will not go till, it will first go till here, then it will go till here. No, that concept is wrong. If you see that the switch is connected to all of them, all the computers, information will come from here, then it will, switch will directly send it to port 6, the information will go inside port 6. See here,
Okay,
the
understood.
information is coming here, right? Let me write the information in the form of envelope. Now the switch will see it wants to go to EE. Now switch knows that what is connected to my port 6, it is EE. So the switch will directly send the information to port 6, forward it out of port 6. This will get the information. It is not that you don't assume that packet will go or the information will go from one port to another in a hierarchical way. It is not true. Suppose I am a person inside the switch. Now I have 6 hands, right? I have 6 hands. One hand is connected to port 1, 2, 3, 4, 5, 6. So if I get something on my hand, first hand, and it wants to go to PC6, I know that my sixth hand is connected to EE, which is nothing but PC6. Obviously, I'll use my hands from hand number 1, I'll pass it on to hand number 6. That's it. Right? There is no hierarchy. There is no hierarchy in the passing of information. Are you clear, Mahesh? Any confusions on that?
I meant actually it is auto generated, right? A and AE. That's why I just confused. If let's say in between got any error, it will be loose or not. I mean auto MAC address, right?
It is not auto generated. For example, if you want to say this guy, this computer wants to go to Google server, what is the address of the Google server? 8888. His address is DD. It will send from AA to DD. It is not auto generated. This computer will add that address. It will find out what is the address of 8888. We will talk that eventually. You will get to know. Now you might
Okay.
have doubt because how it added this, right? Eventually you will get to know how this information is getting added, how this information is getting added. You will get to know, right? Now, only focusing on the switch behavior, if the switch knows, right, information is coming on port number 1 and it has to go to port number 6, then it will forward. Now let's take a small example of a switch, another switch here. Basic behavior I'll tell you and I'll ask you a few questions just to make sure you understand the concept or no. Switch behavior. We call switch as an intelligent device. Why? Because switch knows that what is connected to its port number 1, what is connected to its port number 2, what is connected to port number 5, what is connected to port number 6. Here it knows what is connected to them. Right? It knows. That is why it is an intelligent device. Now, when computer 1, let's take only 2 computers. This is AA, this is BB. Now, this has generated an information 1010 and it wants to go to BB. It knows the IP address. It has now added the MAC address. AA, I want to go to BB. Now the information came here. Where will the switch forward the frame? Will it be on port 2 or port 3? What do you think?
From the switch on the port 2.
Correct. The information that it gets on port number 1 will be forwarded to port 2. Right? Now, let's say that this is AB. Now, let's say that switch gets something ABC as the destination. Now, switch receives this packet on port 1. Where will the switch forward particular port, this particular information? Not sure, right? Because
It will block the information.
can you repeat that again?
It will drop a packet.
It
Exactly.
will block the information.
Right. So that is actually a valid thinking because ABC is not on any of the ports. Right? That is a valid thinking. But you know what it does? Switch is a device. If I know something which is in my table, then I will see, okay, what is the destination. First, I will see who is coming. Okay, port number 1, this guy is coming with an information. I will update the information as port number 1 is connected to AA if there is any information coming. Then if he wants to go to ABC, I will see, is ABC connected to any of my ports? If I don't have ABC, then I will forward that information of every port. On every other ports, I will forward that information to everybody. I don't care whoever it is. I know it is not secure. You should